Hello everyone, welcome back to the Smart Grid lecture series. In this video, we are going to discuss about evolution of electric grid, how this existing modern grid is formed. But that transformation we are going to discuss the history of electric grid. So basically, an electrical grid is a network of synchronized power providers that are connected by transmission and distribution lines and operated by one or more control centers. A schematic of a general electrical grid is shown here. You can see that red colored generating station, then blue colored transmission line, then green that distribution lines. And the distribution line, you have primary customer, secondary customer, or sub-transmission customers. So this kind of structure we already known. So we can see what are the component of electrical grid. So major components as we discuss it is generation. Generation is based upon thermal, hydro, nuclear or renewable energy based generations. Then transmission, uh, high voltage AC transmission or high voltage DC transmission. Distribution also in AC or DC distribution. Consumers can be classified as industrial consumers or commercial consumers or domestic consumers. Let us discuss about some evolution of electric grid. So the earliest electric distribution system were located in the area surrounding the Pearl Street. That is actually built by Thomas Edison in 1882. Actually, these systems use direct current or DC current and is very inefficient, requiring electric generating station to be placed very near to the users, generally within a mile. So these are very inefficient but this is the first form of electrical distribution or electrical generating systems. So Thomas Edison is known as the father of direct current DC distribution. And in 1890s, the further development and refinements of distribution systems were made, and the most significant of these improvements was the design of alternating current, AC current. The high voltage distribution transmission system based upon AC is developed. So this was the significant because these new AC lines permitted electrical power to be transmitted over much longer distance than a DC system. So Nikola Tesla, who is known as the father of alternating current distribution, and in 1896, actually, George Westinghouse built a 11 kV AC line to connect Niagara Falls to Buffalo in Canada, a distance of 20 miles. From that point on, the generation of electricity and the voltage capacity of the transmission lines grew rapidly, while the distance from the point of production to the consumer grew wider. So this resulted in a move away from the localized production of electricity to much larger regionalized producers that could generate more electricity at one location and move it longer distance on the growing electrical grid. So Tesla's inventions for long distance AC distribution were commercialized in competition against our Edison's short distance DC distribution system. So eventually AC won the day due to its lower cost and higher efficiency in distributing energy over long distances. And Sir Adam Beck is known as the father of Ontario's electrical power system. So Buck is actually believed in publicly owned power at cost to the people. So Beck built the power system with the government debit, which was paid back in user fees over the lifetime of assets. So he is actually the father of that kind of publicly owned power generation existing in our system. So these are Adambeck hydroelectric generating station in Niagara. So let us discuss about evolution of Indian national grid. How the Indian power system or Indian grid is modernized. So in early 60s, actually the grid management on regional basis is started. State grid were interconnected to form a regional grid. So India has 5 regions, mainly northern, eastern, western, northeastern, and southern region. In October 1991, northeastern and eastern grid are connected. In March 2003, western region and northeastern region were interconnected. In August 2006, north and east grid were interconnected, thereby 4 regional grids like northern, eastern, western and northeastern grids are synchronously connected, forming central grid operating at one frequency is formed. Actually, in 31st December 2013, southern region was connected to a central grid in a synchronous mode with the commissioning of 765 kilovolt Raichur Solapur transmission line, thereby achieving one nation, one grid and one frequency. And in Indian power system, there are regulatory authorities. Mainly, the top authority is Ministry of Power. Ministry of Power, Government of India deals with the planning, policy formulation, processing and implementation of projects, enactment of legislation in regards to the power generation, transmission and distributions are undertaken. And PGCIL, you might know that Power Grid Corporation of India Limited, which is responsible for national and regional power transmission planning. Then CEA, that is Central Electricity Authority, which advises on matters related to the national electricity policy and formulation of short-term and perspective plans for development of power system. Then there are CERC and SCRC. CERC means Central Electricity Regulatory Commission and SCRC State Electricity Regulatory Commission, which regulate the tariff, formulate the policies regarding subsidies and promotion of efficient and environmental policies at a central level and a state level. They are actually fixing the electricity tariff. You might hear about state electricity regulatory authority is actually finalizing the electricity price in Kerala also. Then CTU and STU. CTU is Central Terminal Unit, the Central Transmission Unit. Then STU is State Transmission Unit. So which is the responsible for the development of efficient, coordinated and economical system of interstate and intrastate transmission line. So these are the point we regarding Indian power sector scenario. And let us have a discussion on what is the impact of electrical grid. So actually, global demand for energy is expected to climb about 25% by 2040. So India contributes about 45% of world energy demand growth to 2040. So India and China has shown the highest demand growth, with each reaching more than 1 billion middle class citizens. Actually, India will grow strongly with its share of global GDP doubling. So, the most increase in percentage, like 45 percentage of energy demand, is contributed by India in 2040. So, what is actually this implies that we need to restructure our grid, or we need to increase more kind of distributed energy resources. We need to uh, increase the power production, and also we need to modernize our grid. So this is some um, details that is available in Ministry of New and Renewable Energy website, MNRE website. Total installed capacity in India as on 31st July 2020, as per Central Electricity Authority. You can divide it as central sector, state sector, and private sector. And total capacity in megawatt is written. In case of a central sector power generation in megawatt is 94,027 megawatt. The percentage of generation is 25.3 percentage. So 25.3 percentage of total generation in India is under central sector. Then state sector, it is 1,03,652 megawatt, that is 27.9 percentage. And in case of private sector, generation is 1,74,298 megawatt, that is about 46.9 percentage. So in India, power generation is 46.9 percentage is under private sector. Then central sector, it is about 25.3 percentage, and state sector, it is about 27.9 percentage. Total power generation is 3,71,977 megawatt in India as on 31st July 2020. So this is actually the various method based upon various sources we are generating the power. So thermal, it is given 62.2 percentage of power production is thermal. Thermal, you can, and then that is splitted into coal, lignite, gas, and diesel. So coal is around 53.7 percentage, lignite is 1.7 percentage, gas is 6.7 percentage, and diesel is 0.1 percentage. So total 62.2 percentage is total thermal power production, and hydro is around 12.3 percentage. It is categorized under renewable energy. Nuclear power production is 1.8 percentage, and RES, that is renewable energy systems, that is basically our solar, wind, and other kind of renewable energy power production is 23.7 percentage. So most of the power production now based upon thermal in India, that is around 62.2 percentage, and renewable energy based power production is now is 23.7 percentage only.